In this video we would like to show you how we've used VPP Honeycomb with BGP support together with OpenDaylight SDN controller to announce IPv6 neighbor discovery information in topology model. BGP has been extended with BGP Linkstate, which allows us to propagate internal network topology outside of the autonomous system. OpenDaylight can receive these messages and create topology model according to their content. This is our environment. We have three virtual machines. VPP is running on VM1 and VM2. Interfaces claimed by VPP are interconnected. Both machines have additional interfaces which are also accessible from VM3, where OpenDaylight is running. These are used for BGP communication. VPP currently doesn't support any interior gateway protocol, which is usually the information source for BGP Linkstate. We have picked the IPv6 neighbor discovery protocol as a source of the Linkstate information. As you may know, the IPv6 neighbor discovery protocol only contains the neighbor's interface identifier, but not the node identifier, which is required by BGP-LS. To fill in the gap between IPv6ND and BGP-LS, we've instructed every VPP to report itself as a node to the ODL, together with all its interfaces being reported as separate nodes. Links are reported between VPP and its interfaces as an additional information to the discovered neighbors. Having interfaces reported as a set of virtual nodes instead of a single node, the application must understand the concept of virtual nodes. For example, router 2 has two interfaces with IPs 20013 and 20023. In the ODL topology model, this router will be represented by three nodes, one for actual router and two for its interfaces. At first, we need to configure the OpenDaylight instance. We need to install these features: ODL RESTconf to allow us to use REST to read topology information stored in ODL. Then BGP Linkstate support, BGP Topology, which manages BGP messages to topology translation, and BGP OpenConfig state to configure BGP peers. We need to configure Honeycomb agents to connect as peers to OpenDaylight. We've set up OpenDaylight IP address here and configured the connection as active. Next, we need to configure Linkstate parameters. All these parameters except of router ID must be the same on all routers which are reported. Router ID needs to be unique for every router. When we start Honeycomb, a BGP session should be established. Each connected peer must be present in the ODL registry, so now we will create them via REST OpenConfig. As you can see, here is the IP address of Honeycomb. ODL is configured as passive, so it waits for connection from Honeycomb. We will check this via RESTconf. Here you can see that the sessions are active. Only IPv6 interfaces are reported, so now we set the addresses for interfaces on both VPPs. We will set 20013 for VM1 and 20014 for VM2. Now we will check network topology data in ODL. Nodes and links with various attributes are used here to model the topology. There are many objects, so to make it more comprehensible, we will show you the graphic representation. We will use a tool which generates a graph according to this data. In this picture you can see that both VPPs are present together with their interfaces. To initiate neighbor discovery, we will ping VPP2 from VPP1. You can see the neighbor entry has appeared in this table. Now we will check whether network topology has also been updated in OpenDaylight. This connection between VPP1 interface and VPP2 interface has appeared after successful ping. Thank you for watching.